Okay, let's start with slope fields, shall we? I'm going to take a look at what I think is the hardest slope field question on this review, and that would be question number 17. So let's take a look at number 17 together. And I'm going to do the whole problem. I take that back. I don't think I'll do part C in this video because I really want this video to just focus on finding the slope field, and C goes a little bit beyond that to the particular solutions. So let's just talk through the slope field piece, okay? So this is our differential equation, which means this is the thing that's determining our slopes. Okay, as soon as I see that derivative, I know this is my slope. And I'm going to be plugging in x and y coordinates here and here, okay? Now, I don't know that I would suggest doing this every time you have to draw a slope field, but like if this was an FRQ where I had to draw a slope field and I had the time to do this, this is probably what I would do just to be super thorough. So I'm actually going to write my derivative up at the top of this paper because I'm going to probably cover it up in a second. Y minus 1 squared, and then cosine of pi x. Okay. And I have 9 coordinates that I'm trying to include here. Slide that over some. I have 9 coordinates, and so what I'm going to do is I'm going to list out what those 9 coordinates are. And I'm just going to start here at this top corner. So that's -1, 1, and then I have 0, 1, and then I have 1, 1. That's just going across the top row, right? And then I have -1, 0, and 0, 0, and 1, 0. That's these 3. And then I have -1, -1, 0, -1, and 1, -1. And I'm going to calculate this equation at each of those 9 points. Now sometimes when you're doing these, you can find patterns and you can lump a bunch of them together. This is one where, except for in one place, there's one place that you might be able to combine some things. But other than that, you're really going to have to crunch each set of numbers separately. The other thing I'm going to write down up here at the top, and I did this on my answer key as well, is I know I'm going to be putting numbers in here for x and finding cosine of like multiples of pi. So just for reference, so I don't have to stop and think about this every time. All my numbers are 0s, 1s, and -1s. So what I really want to think about is what is the cosine of negative pi? What is the cosine of 0? And what is the cosine of positive pi? Just so that when I get there, I don't have to like stop and think about it each time. Okay. Unit circle. Let's do this. Unit circle. Here we go. Your cosine is your x value, right? So my cosine at 0, that's +1. This is 1, 0. This is my cosine value, so this is 1. This is pi. This, I guess I could draw on the bottom half of my circle, but this is negative pi. So these two are actually both in the same place. Pi and negative pi are both here. Your coordinate there is -1, 0, and so our cosine here is -1 for both. Okay? So that's going to help me as I go through and calculate these. So when I plug in -1, 1, what I'm doing is 1 minus 1 squared times cosine of -1 pi. Okay, so this is y, so it's going right here. This is x, so it's going over here. Now, what I really like that's going to happen here is 1 minus 1 makes a 0. And so I'm going to have like 0 times cosine of negative pi, which is -1, but that's just going to make 0. Okay? And so I'm going to go over here to my first coordinate, and I'm going to do a 0 slope there. Okay, here's where my shortcut comes in. Anywhere my y coordinate is a 1, anywhere this is happening, I'm going to have this 0 here, right? And that's going to wipe out everything. So that means that this one is also going to give me a slope of 0, and this one is also going to give me a slope of 0 because of these 1s in the y spot. So that means that I can automatically fill in that all of these are going to be a slope of 0 because I'm putting a 1 in here for y. Okay, let's try the negative 1, 0. So my y is 0 here, so I'm going to have 0 minus 1 squared times cosine of negative pi, because it's negative 1 times pi. Well, that's negative 1 squared, which is just 1, and then cosine of negative pi is negative 1, and so this is going to be a negative 1 slope. All of these have y values of 0, right? So all of these are going to start with the 0 minus 1 squared, 0 minus 1 squared, which means that over here it's going to be 1 times something. 1 times something, because 0 minus 1 is negative 1, negative 1 squared is positive 1. Okay, so this one will be multiplied by a cosine of 0, right, because that's 0 pi. Well, cosine of 0 is 1, and so this one's going to make a 1. This one will be cosine of 1 pi, which is also a negative 1. Okay, so these two are the same and this one's different, which you'll notice coincides with what's going on up here. Okay, so that's these 3 dots. I'm going to have a negative 1 and a positive 1 and a negative 1. Okay. All right, let's do the same thing for the next 3. So I'm going to do, my y value now is negative 1, so I'm going to have negative 1 minus 1 squared. That's going to happen with all of these. Negative 1 minus 1 squared, negative 1 minus 1 squared. That's negative 2, and negative 2 squared is 4. So this is going to be 4 times something. This is going to be 4 times something. This is going to be 4 times something. But then these are going to work, well, okay, I guess I shouldn't say that. These x values are going to work the same way these x values did, right? So this is going to be cosine of negative pi, which we know is negative 1. This is going to be cosine of 0, which we know is 1. And this is going to be cosine of pi, which we know is negative 1. So here I'm going to get a negative 4. Here I'm going to get a positive 4. Here I'm going to get a negative 4. And so this row is going to look a lot like this one, except steeper. So negative 4, positive 4, negative 4. Okay, and there's my slope field. Notice with this one we didn't have to actually graph like a function here. I was able to just draw the slope field. It does ask me to find a particular solution, but I think I will do that in a separate video where we talk about particular solutions. But that's really the idea with slope fields. The only other one that we could maybe talk about here in this same video is this number 14 with the slope field. So it says pick which one of these equations might come from this slope field. And it does give me an initial condition of the coordinate 0, 1. So that's this right here. So what I would kind of do is sketch what might this graph look like if this is its slope field. And so I'm kind of seeing it come down like this, but then notice it's starting to like flatten out. Okay, and right here at the x-axis you've got a straight horizontal line, so you actually have like an asymptote going on down here. It actually should be right on the x-axis, but and so the same thing's going to happen here. This kind of curves down, but it flattens out toward the end, and you're getting an asymptote here. So we just want to know which one does that match up with. A lot of these you can just do visually. All right, and notice I'm doing this without a calculator. If I had a calculator, I could graph these and see what they actually look like. I'm looking for something that looks like that. The cosine function does this, right? But it doesn't flatten out like this. It keeps curving, so it's not that one. 1 minus x squared, that's the same thing as like negative x squared plus 1. This is an upside down parabola. This is a graph that looks like this. Okay, but again, this keeps going, and I'm not seeing that. I'm seeing a flattening out here, so it's not this. E to the x is an exponential function that looks like this. Okay, That's definitely not what I'm seeing. I guess I see that here, right? I see this flattening and kind of curving upward, but then it curves back down over here, and that's not what e to the x does. We would see it kind of shooting up this way. So it's not that one for sure. This one might be hard for you to visualize what this looks like. I think this is actually like a semicircle. I might have to cheat here and use a calculator, but 1 minus, this isn't a common parent function or anything. Yes, so it's really tiny on my graph screen. But yeah, it's basically a semicircle, but it's got like endpoints here, okay, because of those domain restrictions. Once again, we're not seeing that asymptote behavior here down at the bottom. But this one, now I have no idea what this graph looks like off the top of my head, 1 over 1 plus x squared. But this idea of there being an asymptote, like where my tangent line is going totally horizontal or close to horizontal, that idea of there being an asymptote means that my y can never equal 0, or my y is going to keep approaching 0. It's going to keep getting tinier and tinier, but it can never equal 0. Well, think about the way this function works. This function has a 1 on the top of it, so I can never get that y coordinate to equal 0. Okay? This is going to have y is never equal to 0, and I'm going to have an asymptote there, because I can get close to 0, right? I can make the bottom really big, which makes my y coordinate really small, but I have an asymptote there, and that's exactly what I'm seeing here with this graph kind of flattening out like this. So E is the correct answer here. Okay, I will pick up in another video, and we'll talk about some separable differential equations.